Okay, and this is for Aiden and Mackenzie and Carter. Okay, all right. Okay, we are starting chapter 7. I'm not sure how far we'll get into chapter 7 because I'm going to do a lot of like front loading and like this is connecting dots with what we were doing before to what we're doing now, okay? So we'll get a little ways. We'll get a little ways, but not too far. I'm going to write a bunch of stuff up here, so feel free to put it in the margins, whatever. Here we go. I might put some stuff down below here, okay? Just kind of connecting the dots. So here we go. First thing I want to do, what? Yeah, probably. First thing I want to talk about is variables. Variables, like what we call things, right? Okay. So I'm going to make a little table-ish thing, and let's do for a sample. Okay, I'm going to make a table that looks like this. I don't know how many rows I'm going to make, but we'll just do it like this, okay? Blah, 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 blah. This guy's sample, this guy's population. I didn't make that very good. Let me scooch that over. Sample and population. Okay, those are my two columns. Okay. Sample, population. Let's talk about variables that we use. Where'd my chair go? Okay. One of the very first things that we use is like total number.
Lowercase capital N.
Yeah, lowercase n, capital N. Which one is which?
Sample is N.
Sample is lowercase, population is capital N, okay? So if you're talking about the number of items or people or whatever in your sample, you're using N or N. Okay, total number. Let's talk about mean.
X and mu.
Mean is mu. Which one's mu?
Sample.
Population is mu, right? So do you remember before where they would say, like, the average of all men is this? That was your mu. And then, like, of the 27 men that we shove in an elevator, their average is this. That's X bar, right? So X bar and mu are the variables that we use. This is going to come into play, like, really super important this section. Or this chapter, this whole chapter.
Different than the X bar that we used for. No, it's not.
No, it's going to be the same. Okay, then we have standard deviation. Okay, we usually use sigma, which is the population standard deviation. Do you know what the symbol is for standard deviation of a sample? We probably haven't used it a whole lot. Standard deviation of a sample, what? They call it S. It's boring. S and sigma. It's a circle with a hat. Like a circle with a little hat on it. Okay?
Cursive O.
It's like an O with a little pat. Whatever. Okay, anyway. All right, now, here's some, anything else that we've dealt with? I mean, we have like P and R and Q and all those things, right? But we're done with those now. For now, kind of. Okay? Actually, we have some P's. We have some P's, but they're different P's. We do have different P's. Okay, so this is new stuff. A couple new things, actually. Two things. Two new things. Just 2 more rows. Actually, just 1 more row. 2 more rows? 1 more row.
I don't know. Quit changing your mind.
We'll go 1 more row for now. Okay, we have proportion. What does proportion mean?
This in comparison to this.
Yeah, like the proportion of people that are blue-eyed, which we're going to talk about here in a second. The proportion of people that are blue-eyed, like that would be like a percentage, right? So kind of like P, right? So we have P, and then, actually, this one is P hat, and this one is P, okay? So P for the population is P. P for the sample is P hat. He has a little hat on him, and it's a triangle hat.
Is he really called P hat?
He is called P hat. Like, seriously, let's go down here. P hat. P hat.
Instead of adding in the extra huh, that's usually silent.
I don't know. They don't have him written down. But anyway, he's written down right here, but they don't call him P hat. But that's what we call him, is P hat. We literally call him P hat. Okay, so P and P hat. All right? And there's a little bit of a difference between the two. So there's my variables that we have going on, right? Okay? Okay, remember those. Okay? It's very important to distinguish between the two. Okay, here we go. Chapter 7 has 3 sections and only 3 sections to them. It is 7:1 and 7:2 and 7:3. And in 7:1, it is estimating a population proportion, okay, which has to do with P's and P hats, okay. 7:2 is estimating population mean, which has to do with mu and X bar. The third one is estimating population variance, which I don't use very often, but anyway, variance and standard deviation, which is, for variance, it is sigma squared and s squared, or sigma and s for standard deviation, okay? Now, after we do 7-1, the process for 7-2 and 7-3 are going to be identical with just a little bit different of a formula, okay? So, pay attention real good in 7-1 and your life will be hunky-dory for the rest of the chapter, okay? Like, it will be significantly easier. All right, here we go. All right. We've talked about this before, why we use a sample, right? We use a sample of a group of people to, like, talk about something happening because we don't want to survey everybody in the entire population. Like, sometimes we can't even do that, right? Like, I can't get access to everybody. Okay, so let's say we have a sample over here. And I'm talking about blue-eyed people. So the thing that I want to talk about is blue-eyed people. Blue-eyed people. Okay? All right, and so what we're going to do is we're going to sample everybody in this room. We're going to talk about blue-eyed people. Okay, so how many?
Wait.
There's 2,
Wait.
2, 4, 6, 8, 10. We'll say 12.
There's 6 blue eyes.
We can use them.
Oh, good. 6 blue eyes out of 14. Are we going to do 15 with Mary? We'll go 6 out of 14. We'll go 6 out of 14. Is Mary a blue?
No.
Okay, so 6 out of 14 is blue-eyed, which would be, what is a decimal?
I don't know. Divide by 2 for each.
0.4
3
something.
over 7. 3 over 7
What?
Whatever 3/7 is.
Whatever 3/7 is. I don't know what that is.
Divided by 7 is 0.4.
Exactly? Exactly? 0.4?
0.4285 blah.
We'll go 0.428, so we'll go 0.43. Okay? What variable do we put with that?
That is our proportion.
And so we call it what?
P-bar.
P hat. P hat.
P-hat.
P with a hat on him. Okay, so that is P hat. Now, here's what we're doing this whole chapter. Are you ready? In this room, 43% of all the people in this room, besides me, because I don't think I was counted on that, right?
Yes, you are. You are right.
I didn't count that. I didn't count me. Because 14 students.
You know
Okay,
what,
so
Lily? Shush.
43% of all the students in this room,
Funny.
and the people who are absent, the 3 that are absent, 43% are blue-eyed. Okay, is it fair or accurate for me to say that 43% of all people are blue-eyed?
No.
No, that's not gonna be the same, right? Now, 43% is going to be what's called the best write that down. Estimate. We're going to talk about that here in a second. It's the best point estimate for the population. That number is the only number I have to go off of to determine what percentage of people are blue-eyed, right? So it'd be better than just me guessing, right, to take 43%, because at least I have some data to support the 43%. That's going to be the best and most accurate number I have to represent the number of blue-eyed people. It's the best point estimate I've got, right? Aside from surveying the entire population, that's the best number I have to go off of is 43%. Now, it may not be accurate, but it's going to give me the best. So, if I were to estimate the proportion for the population, I would say somewhere around 43%. Now, here's what's not true. I just asked you, is it true for me to say that exactly 43% of all people are blue-eyed? No. What would be better is to do something called a confidence interval. Okay? A confidence interval. And that would be something to the effect of me, instead of exactly 43%, instead of me saying exactly 43% are blue eye, I would say let's go between 40% and 46% are blue eye.
Can we not?
Okay?
We can choose that area.
Now, why did I subtract 3 and add 3?
Because you want it to be in the middle.
Because I want it to be in the middle, right? Okay, but why 3%?
Because that's your standard deviation.
The formula that tells us what to add and subtract is going to be based on the standard deviation. So yes, I made that up because I don't have any other data to do that, but that's what we're going to do, right? Is rather than saying definitively exactly 43% of all people have blue eyes, it's more accurate for me to say that somewhere between 40 and 46% of all people are going to have blue eyes.
But I don't like that.
Okay, now, I understand your frustration. I went from giving you an exact number, hold on, I went from giving you an exact number of the people who are blue-eyed to now a range, like somewhere between this, right? Like if Tate came in this room and he was like, I want to know what my grade is for a test, and I said, somewhere between like 80 and 100. He would be like, no, I'm not happy with that, right? But that would be more accurate for me to say somewhere between 80 and 100 than for me to say it was exactly a 95 and be wrong, right? Does that make sense? Okay?
It'd be better to say like about 43%.
Right. But this is essentially saying about 43%.
But then you put like restraints on it.
Right.
And this probably isn't accurate. So
What?
it's probably outside of that range. I feel like you just assured me it's between that range.
And I will tell you how confident you can be.
Isn't the sample standard deviation?
So the sample standard deviation was 43%, and we're saying that the population standard deviation lives between 40 and 46%.
No, to find the percentage. To find the percentage, is it based
To find the
on
percentage,
our-
it's based on the sample.
the
yes.
sample standard
Yes, the sample standard deviation. Yeah, basically. In a nutshell, that's kind of how that's found, type of thing. Okay, does that make sense? So I can't definitively say exactly 43% because we only surveyed a sample, right? Maybe we got more blue eyes than normal, or less blue eyes than normal. So it's more accurate for me to say somewhere between 40 and 46%. Okay. Now I added and subtracted 3% each time. What tells us what to add and subtract each time is the formula, right? We're going to have a formula down below, okay? So let's talk about this. I just made reference to something called a point estimate. That is the only thing that we have to go off of. So it says the sample proportion for my example above was 43%. 43% is going to be the best estimate of the population because that's the only number I have to go off of. So 43% is going to give me the best number to go off of when I don't know the whole population, right? The sample is going to be the closest I can get, right, to the actual population because I don't have access to the population. Is that confusing? So the best point estimate. What? Yeah, correct. Right. And then that, if I gathered more data, so if my N got larger, then that number would be a better point estimate, right? So whatever my sample is, that number will be the best point estimate. If I increase my sample, that makes it even better. Yes, I get it. Yep. Okay, so example 1. This is kind of a weird, wonky example, but whatever. The chapter problem included a reference to a Gallup poll, they do these every once in a while, in which 1487 adults were surveyed. Okay, let's give a variable to 1487. N. Lowercase n, right? Because that's my sample, okay? And it said, oh my gosh, 43%. How lucky did we get?
That's crazy.
That's crazy that that's the same number. 43% have Facebook. Okay, so they're talking about something completely different, not blue-eyed people. 43%, that is P hat, because that's the proportion from the sample that have Facebook. Based on the results, find the best point estimate of the proportion, not the sample, of adults who have Facebook. If they give me this information, what proportion of the population could I guess have Facebook?
We need a formula.
You don't need anything else.
So we just go 40 to 40.
No, 43%. Right?
1487 divided by 0.43.
What are you talking about?
I don't know.
Well, you don't
No,
need a
it's just 43%.
Wow.
P hat is the best determination of what the actual percentage is, right?
So they
That's
just
the only thing.
like
They
that.
just,
What
what?
happened to the
Trick
range from
Right here. The sample proportion, which is 43%, is the best point estimate for the population.
Oh, we want just a point estimate.
They just want the point estimate. They don't want a range because we don't know how to find the range yet, right? So they're just saying if you had to tell me approximately, what percent would you use? I'd use the only percent that I have, which is 43%, right? That's the only thing I have to go off of for the number of people that have Facebook because my sample told me 43% had Facebook. So if I surveyed the entire population, it might not be exactly 43%, but it's going to be close, right? Maybe. Probably. Okay. All right, confidence interval. Here's what that confidence interval is, all right? Now, this is a little bit hard to explain, but just hear me out, all right? Confidence interval is going to be that range. So rather than saying definitively 43% have Facebook, I'm going to say from this to this, right? That develops a confidence interval, right? Because let's say Tate walks in here, and instead of saying that he got exactly a 95% on the test, I say it was somewhere between a 90 and a 100. He might walk in and I say, I think you got a 92, in which case I'm wrong, right? But if I said somewhere between a 90 and a 100, he'd be like, okay, because that's correct, right? This is correct. Don't write this down. That's correct. This is incorrect, right? So in some cases, it might be better for me to tell him a range than to tell him an exact number and me be wrong, right? Because I'll never hear the end of it. He'll be like, you told me I got a 92 and I actually got a 95. Actually, that wouldn't be so bad. If I did it the other way around, he'd be real pissed.
Yeah.
If I told him I got a 95 and he actually got a 92, then we'd be in real big trouble. But anyway, so it's better to give a range, okay? And that's called a confidence interval because I can be more confident about this answer than I can about saying an exact number. A confidence interval. Now, this gets really a little bit hairy, but hear me out. Are your listening ears on? Okay. You can change your confidence interval, right? Here's what can happen. You can change your confidence interval. So, let's say with my 43%, right? 43% was my middle, okay? And instead, I'm going to say somewhere between 40% and 46%. But I am 90% confident, that's pretty confident, that the number of blue-eyed people lives between 40 and 46%, right? Okay? If I want to be more confident that my range is correct,
Make a bigger range.
make a bigger range. So let's go.
50 and 60. Or not 50 and 60. Sorry, 30 and 60.
Let's go a little bit smaller than that. Let's go like 38 to 48%. Okay? Now, I'm 95% confident. I'm more confident, but my target is bigger, right? Okay? I'm more confident, but my target is bigger. Okay? Now, let's say I want to be 99% confident. I'm going to make my target even bigger. So I'm going to go like 36% to 50%, right? Now, this is where you have to give and take a little bit, right? Okay? If we're talking about like blue-eyed people, I could say that somewhere between 40 and 46% have blue eyes, right? That's not a lot of margin of error, right? Like that's kind of a small range. You get a pretty good idea with that, but I'm only 90% confident, okay? So would you rather be 90% confident that the number of blue-eyed people is between this range, or would you rather be really super confident that the number of blue-eyed people is in this range? Because this range, 36 to 50, that's like, well, that really narrows it down, right? Like you're kind of frustrated. 36 to 50, that's like a huge range. And you're like, well, that didn't tell me anything, right? So you have to pick and choose. Do you want to be really confident and have a wide target, a wide range? Or do you want to be less confident, right? 90% confidence, still pretty confident, right? A less confident, but have a smaller range, right? That's what you have to decide. And it depends on what you're talking about, right? A lot of times they'll put us right here in the middle and say we're going to be 95% confident and we're going to be in the middle of the road, right? So the bigger the confidence, write this down. The more confident, I cannot write, more confident equals a wider range. Right? If I want to be really confident that I'm going to hit a target with a bow and arrow, what am I going to do to the target?
Make it bigger.
Make it huge on the wall, right? I'm going to draw my target bigger if I want to be more confident that I'm going to hit it, right? Okay? So that's how that works. You change your confidence level based upon like that type of thing and other things, whatever. Okay? All right, now let's talk about what these guys are. Whoop. Okay. I'm gonna relate this stuff to a bell curve real quick, okay? So let's say my bell curve looks like this, okay? And my P hat, which is 43%, lives here, okay? If I'm doing a 90% confidence interval, we said, and I just made up these numbers, that we're going from 40% to 46%, right?
That means is
That
on the
means
outside, so
10%
that way,
is on,
5%
yeah, that means 10% is on the outside, or 5% here and 5% here, okay? They call this an alpha value.
Whoa.
This little symbol is alpha. A-L-P-H-A. We're starting to get into Greek symbols. Okay, your alpha value is the stuff on the outside of your confidence level. So if I want to be 90% confident, or 0.9, then my alpha value is 10%. That means the stuff on the outside. And again, Josie just said that means that 5% is on the right and 5% is on the left, right? If I was doing a 99% confidence, are you listening? 99% confident, yep, Reese just said 99% lives here. That means only 0.5% would be here and 0.5% would be here, right? Okay, we'll get into that more later. You're not going to understand what that means now really too much, okay? Good? Okay. You need really quick, and maybe this is, what time do we get in here? We'll see how much further we get. We might get like one more example done. But what I want you to do is I want you to find this chart. The one that's positive and negative. Like that guy. And I want you to look on the positive side. I wonder if I can have this on my sheet. Let me look and see if I can find. I bet it's there. I bet it's there. No, I don't know. Did I put my charts in here? No, there we go. Sometimes I will have my positive negative chart in here, but I don't.
Mrs. Conacher,
What?
Just take a picture. Right?
Hold on.
is that like, does the range account for like sample compared to population?
What we're trying to do is we're trying to find an estimate for the population. Because I don't know I don't know the population. I only know the sample. So I'm trying to come up for an estimate for the population.
But like, if you know like the total number of people, like in the world.
That's gonna change every like X amount of minutes.
Like, it's not the.
Where's my positive side? Right here. Here we go.
Full survey of the world, get all the people, and then a mom could pop out a kid.
No, but
And
I'm saying
someone's
like,
dying.
I'm saying
A mom
like,
could
if
pop
our
out of a
sample's
kid.
like 10
A
people.
mom could pop out a kid.
If our sample's like 10 people and the population
Or
is
someone
100,
could keel over and
that's
die
more
midway
accurate than
through.
our population.
Okay, real quick. On your positive side. On your positive side. Are you guys all finding me? Down in the bottom right corner. You need to see. Does everybody have that 0.01 is 90% confidence level and 1.645?
Yeah.
Do you have 0.05 is 95% with a 1.96? I'll tell you what these numbers mean here in a second, but I want to make sure that they're on there. 0.01 is 99% at 2.575 for a Z. 20% is 0.8, 1.28, 0.02 is 98%, and 2.33. Do you have those on there?
I don't have the
No.
first line.
You don't have the first what?
Like the
What's our alpha value?
Oh, you don't have the alpha values?
No.
I don't know that you need, well,
Nor the bottom two.
Yeah, we're missing the bottom two in the alpha
I
value.
have the bottom two. I don't have the alpha.
Why do we all have different charts?
all right.
Mine have been
I don't know, because these have been reused and used and reused and used and reused and used. Okay, so here we go. Here's what I want you to do. If you're missing something, you're going to take a Sharpie, and you are going to write down the stuff that you need. Here's my Sharpies. Black. You pick whatever you want. Okay? I got all sorts of different colors of Sharpies. You're going to write down what you need, and you're going to put tape over top of it so it doesn't smear. Yeah?
Cool
Or just
beans.
let it dry.
Ah. Yeah.
Hit it
Well,
with-
no, if you let it dry and then you like it scratches on something,
Let it
it will scratch
dry.
off.
You got
I mean,
that?
I already have this.
Black, I got a black.
I don't like it.
Tape,
I
is there
thin
tape
tip
back
Sharpies.
there?
Ellie has one that they use. I don't see any more.
Okay, this is what I have. It doesn't matter what color you have. Whatever you
Oh, well, never mind. I'll
If
just
you wanna
wait
wait
for
for
the
black,
Sharpie to
wait
work
for
its
his.
way with the.
Anybody else need one?
I
Yeah?
want a black
Sharpie.
Orange?
Can I have it? Oh.
Okay.
Break
Yeah.
you, Billy.
Yeah.
I'm
Yeah. Oh, yeah. Tape? Do you need tape? You got tape? Here you go. There's some tape.
I need
Add
one.
whatever onto that chart that you need and put tape over top of it. Add whatever onto that chart that you need and put tape on it.
Hurry up.
Can you
Awesome.
bring
Okay.
that thing
Hurry
back to life?
up.
Oh my
Black
god.
Sharpie.
Okay.
Can you bring it alive?
Oh,
Never mind that.
Oh no.
Oh
Died.
no! It died. Oh, we're still taping though. Ha. Okay. All right. Who else needs? Anybody else need?
Hold on.
Okay, just make sure that those guys are all on there and put tape over top of him. Whatever you physically write needs to have tape over top of him so that he doesn't scratch off. I've been doing this too many years to know how that works. Okay, and just make sure I get your Sharpies back because this is all that I have.
Can you?
You got tape?
This is all that I have.
I got one.
Where's the tape?
And then we'll do one more example and then we'll be done for the day.
This already has it on it.
And you don't need any, what?
Then don't add it.
Then you don't need to add anything. And
Perfect.
you're just good to go. But if you don't have any of those things on there, make sure you add them. Okay, this is superly important and you will use it every day for like the next 3 months.
What about on Saturday? Will you use it?
You should be using it on Saturday because you'll probably have missing assignments by Saturday. And you should be doing those assignments on Saturday and Sunday.
I doubt it.
So every day.
Should I check on Carter's? Oh, look at
Tape.
that.
Someone tape me.
Oh, it doesn't.
Oh, Carter, Ellie's fixing yours for you. Aiden and Mackenzie, you're on your own. Sorry. You gotta add your stuff, okay? And if you need to, you can always add with my Sharpies. No. No, we're gonna do one more example and we're done for the day. We're gonna do example, I don't know, 3 or whatever, 2 or 3, whatever it is. Because I'm gonna show you where these numbers come from.
Ellie, I don't think the price.
Anybody else? Sharpies?
I need tape.
I will recollect Sharpies. Thank you, darling. Sharpie, are you done with your Sharpie?
I guess.
Okay. Tape? Are you done with tape?
Send the tape my
I have a couple more tape dispensers. Send it that way. Send it that way.
Send it that way.
Send it on. Okay? All right? Good? Oh. Ah. All right.
Nice throw, man.
Okay.
That's funny, dumb.
Okay? Good?
being a brat.
All right. What the heck do these numbers mean? What the heck do these numbers mean? Here you go. I'm going to show you what these numbers mean with one example, and then you'll know what these numbers mean. All right, so we understand how these correlate, right? Like if it's a 90% confidence level, then on either side is 10%, right? 5% on one side, 5% on the other. Like these correlate nicely, right? Like we understand how those work. Got it? Yes, do we? And you're like, what the heck does that mean? These are your Z-scores. You don't have to write that on your sheet, but these are your Z-scores. How the heck do they get those Z-scores? Here you go. I'm going to show you. Let me go back to your sheet. We're going to go to example 2 that is on right here. Okay. Okay, on example 2, find the critical value that corresponds to 95%. Okay? Now, they call this a Z of alpha over 2. Don't worry about the alpha over 2 part. Just worry about it being a Z. Like, they want to know the Z score for 95%. Okay, now, here's the deal.
Divide by 2.
What they're meaning is, if I'm looking for 95%, write this in here so you can understand where these numbers come from. Ready? 95% is not the same thing as the 95th percentile, okay? 95th percentile means 95% of people are lower than you, right? And we've done that before, like 9, 5, 0, 0, we find the Z-score and all that stuff, okay? The 95th confidence level means like the middle 95%, right? So 95% lives in the middle, okay? And I want to know what this value is and what this value is. I know that both of those will be the same, but plus and minus, right? Okay, now, we know from the chart that it's 1.96, but where did they get that? Okay, so here's the deal. If this is 95%, what percent lives here? And what percent lives here?
Oh, never mind.
2.5%, right? And 2.5%. Okay, so let's pick on like this number right here. If I'm trying to find this Z-score and I'm looking it up on the chart, it's going to look up everything that is back that direction. What percent is back that direction from this guy? 0.9750. Do you see where that comes into play? 95% plus the 2.5%. All right, now, if you're looking it up backwards on the chart, for those of you who can't see my chart, like you're looking up on the positive side, and you have your Z-scores here and here, and you're looking up the 4 digits in here, you are looking up the number that is closest to 0.9750, and that number is 1.96. 1.96 and negative 1.96. Okay, now, if you would have looked up this number, what number would you actually be looking up on the negative side? 0.0250, right? If you look at 0.0250 on the negative side, do you get 1.96? Probably. Exactly 1.96. Okay, so that is where those numbers come from, right? It's talking about the middle 95%. It's talking about the middle 90%, the middle 80%, whatever all of those are on there. Those left-hand column talks about the z-score. What z values are associated with the middle being that percent. Does that make sense?
Yeah, sure.
Okay, and you don't know what to do with that information from there because, like, we have to learn the formula and stuff. But that's where your z comes from. So, it says find the critical value. They will call that a critical value. That corresponds to 95%. And they call it a z of alpha over 2. It's just a z-score. But it's plus minus 1.96. Right?
So
Yeah.
The reason it says alpha over 2, that's because it's 90%.
Because it's like on either side. So it's like alpha over 2. Like 95%, 5% would be your alpha, but divided by 2 is 2.5% on either side. That's what they're getting at. So this is the z-score for 2.5%
So like if we
on either side.
If they like want like 91 or 92, like something they don't give us,
So then you would
then we have to.
are you looking at your homework assignment? So you're going to look up like 91% lives here. So then what percent would be here and what percent would be here?
Wait, could you do 4.5?
4.5%, right? 4.5%. So what would be to the left of this mark right here?
955.
0.9550. You would look that up and you find that z-score.
Question: could they give you a z alpha 5,
No, you don't have 91%.
or is it always going to be
0.9550 would be
1.69?
1.70 would be closer. 1.70 would that's what that would be. Make sense? Yeah. What?
Will it always be z alpha over 2, or could it be z alpha over like 6?
No, it'll be always 0 of alpha over 2 because you only have the two tails on the either side. Yep. Okay, so just so you know, that's what those numbers mean. I'm not just filling you full of crap and a bunch of numbers, although it could be. You would never know. Maybe. I don't know. So anyway, there's that. Hey, that is a thing. That's a thing. Here's the formula that we're going to get to tomorrow. Okay, goodbye people who are watching this. Yeah.
Here's this.